Okay, so we're going to look at the second part, which is 5, 6, 7, and 8, that asks you to find the scale factor. Now, the scale factor was pretty simple up top. Okay, when we looked at the scale factor up top earlier, all we had to do was figure out the changes to see if they were similar or not, and we got the scale factor. But we were thinking in one dimension. Now we're thinking in two dimensions. Surface area. Any kind of area is two-dimensional, okay? Now let's do a little bit of a review. Do you remember when I gave you a rectangle? And I said, okay, if a rectangle has an area of 10 centimeters squared, and remember, a rectangle is base times height, or length times width, and I told you, well, what's going to happen to the area of that rectangle if I double the base and I take 1/4 of the height? And I asked you, what would happen to the area if I doubled the base? I don't know what the base is. I just know I'm going to double it. And I don't know what the height is. I just know I'm going to take 1/4 of it. But I know that it's going to affect my area. I know my area, my original area is 10. So what I did was I took the original area and I multiplied it by the scale factor for the base. This is my scale factor for the base, times 2. And I multiplied it by what I'm scaling the height as, 1/4. So I ended up with 10 times 2, 20 divided by 4, which is 5. So my new area would be 5. Remember, you multiply by every dimension, so there's two dimensions, which means two multiplications. Now, when we're going backwards, you've already been given the surface area. So we have to actually now go back and find how did we change the two figures, only knowing the surface area, not the area. This is one-dimensional. Surface area, now we've got two dimensions to worry about. So, if you remember, your scale factor is your new divided by the original, right? But we're going to run into a little bit of a speed bump here with surface area, and I'll show you. What's the new surface area? 275. What's the original? 396. So, how did I get from 396 to 275? Well, I did 396 times some number to get the new one. But here's the catch. Is this one-dimensional or two-dimensional? It's two-dimensional. You have to multiply twice, right? Two different factors. We don't know what those factors are here. So I'm going to multiply by k squared. This is area. I multiplied by two different factors. The original area, just like over here, what was the original area? It was 10. And I multiplied by how many different factors? 2, right? 2 over 1 and 1/4. Two different factors. I don't know those factors here. I just want to know what my final scale factor is. Over on this one, my final scale factor actually would have been 2 over 1 times 1/4. So my final scale factor overall was 1/2. If I multiply the two dimension changes. Here you don't know the individual dimension changes, but you can figure out the actual scale factor without knowing what you did to each dimension. So I multiplied to get 1/2. So what I'm going to do is I'm going to do 275, and I'm going to divide both sides by 396. And so I'm going to end up with k squared equals 25 over 36 when I reduce this. And if you remember Pythagorean theorem, or anytime you have a squared value, I don't want k squared, I want k, so I'm going to square root both sides. There's always a positive and negative square root, but we don't have negatives when we talk about length and measurement. So your scale factor is 5/6. Okay? It's 5/6. Or, in other words, this one is a 6:5 ratio of this one. I multiplied each dimension by 5/6. Or, sorry, when I multiplied all the dimension changes together on the original, like here when I multiplied the original double base 1/4 height together, I got 1/2. when I multiplied all the dimension changes together here on this one, I got 5/6. And I did k squared because it's two-dimensional. That's area. I'm running low on battery here, so let's do one for volume. Let's look at 7 and 8. Well, let's actually look at 7 and 8. 7 and 8 now, what am I looking at? I'm looking at volume. Volume. So now I'm looking in 3 dimensions, which means I'm going to have k what? Cubed. So I multiplied 20,000 times 3 factors of some sort. I don't know exactly what they are, but they all came together to make k. But I know it's 3 factors, so k cubed. And that gave me my new volume of 10,240. So what I'm going to do is I'm going to divide both sides by 20,000. And so k cubed is going to equal, and let's see here, let's use the magic calculator. You have 10,000, and that's an extra 0 because who knows what I'm thinking. 240 divided by 20,000. And when you convert that to a fraction, you get 64 over 125. Now, as up here where I took the square root because I was looking for k squared, now I'm looking for k cubed. I'm going to take the cube root. So k, how do you take the cube root in your calculator? I don't know if you can see this very well, okay? I'm taking the cube root of 64 over 125, right? Okay. On your calculator,